We are starting deep learning fundamentals today. We will talk about why we need tensor. In in this we will consider the difference between list, array and tensor, and during the discussion we will consider the heterogeneity, size, dimensionality and optimized computation. If we think about list, suppose we have a list 1, 2, 3, and suppose we have 4.0, another list inside it, and now we are printing it. So here this is integer, these are string, this is float, these are another small list. So this represent list support heterogeneity, and if you want to increase the size of list 1, we can use the append function to arbitrarily add anything, add any value inside the list. Suppose we are appending 10 and printing list 1 again. So here we get the 10. So list has the dynamic size, and if we consider the dimensionality, list is usually one dimensional, but it can contains list of list, that is creating another list here. This is a list 1 2 3, another list 4 5 6, and the third list 7 8 9. These three lists construct a list of list, that is list 2, and list 2, that is a list usually not optimized for computation. We there are something mathematics calculation, that is element wise multiplication, dot product calculation, matrix multiplication, matrix addition. These are not optimized in list, and list doesn't provide any functionality to directly calculate them. Now talk about the array. We will consider the numpy array here. We can convert the list 2 directly inside the numpy array. And we know numpy is widely used for scientific calculation and for data analysis, and numpy is highly optimized and efficient for this type of calculation. So if numpy is highly efficient and it can do also the matrix calculation efficiently, and that is in the case of linear algebra and in the case of statistics, numpy provides various functionalities. Then why we need the tensor? Okay, we will come out this question. Now if you think about heterogeneity, array doesn't support the heterogeneous. That is, if we want to calculate, if we want to convert the list 1 inside another array, suppose array 2, let's see what happens. So value error, the requested array has an inhomogeneous shape. And now numpy array doesn't support the heterogeneous value, that is it could be only integer or only float or only string, and we can the arbitrarily change the size of the array, as it is usually has a fixed size. And the dimensionality, it can be one dimensional, two dimensional, and multiple dimensional. And numpy is optimized for matrix calculation. Now talk about the tensor. Tensor is usually used in the purpose of machine learning and deep learning, where we need to calculate the back propagation, loss function, cost function, that often requires the differentiation thing. And tensor can perform this differentiation, and it provides the functionality that automatically compute gradients for tensor during training, and it enables easy implementation and optimization algorithm. We can consider the gradient descent algorithm for this. But numpy arrays lack this type of support. In deep learning or machine learning, we need something faster, so we often use the GPU or TPU for this. Tensor can be processed on GPUs or TPUs, but numpy array, these only work on CPUs. These are the another thing that why we use the tensor. And for the multidimensional data, that is high dimensional data, 3D, 4D, 5D, and many higher dimensional, tensors natively support, and it is very efficient to handle the high dimensional data than the numpy array. If you think about the parallelism, that is performing many operations side by side, here tensor is much more efficient than numpy array. And tensors in PyTorch and TensorFlow are designed for optimized performance in deep learning. They leverage optimized backends like CUDNN, MKL, and others for tensor operations, resulting in faster execution times. But numpy arrays are efficient for general purpose scientific computing, but lack the deep optimization for machine learning tasks that tensor provides. And tensor also support the dynamic graphs, but numpy doesn't support it. So these are the things why we need the tensor actually. I hope you understand this thing better. Now if we consider, that is we didn't perform, that is anything with the tensor, let's create tensor for list 2. We are keeping it inside the T1. How we can create the tensor? If you want to create tensor for list 1, let's see what happens. This also doesn't support the heterogeneity, and the dimensionality, it obviously perform the high dimensional data, and this has the fixed size. Now if we want to calculate, or if we want to perform the differentiation for this, suppose I am having a number 3 that we will use for the we are considering a function that is 4x cube. So what will be the differentiation for the function 4x cube? That is 12x square. So calculate it. Now if you want to know what will be the value of x, that is after performing the differentiation, what will be the x? So x is 3, 3 square is 9, and 9 into 12 is 108. Let's see if it provide us the first derivative correct or not. Yeah, we get 108 for it. We can also perform the second derivative, third derivative, and like this. I hope you understand it. So we will continue the discussion, the fundamentals in deep learning gradually. Thanks for watching.